What happens when a space mission fails? When the rocket doesn't launch, when the lander never calls home, when billions of dollars, years of planning, and the hopes of thousands vanish into the void? Is that the end of the story? Or is it the beginning of a better one? Because in space exploration, failure isn't unusual. It's expected. We are building brand new machines, sending them into impossible conditions, trying things no one's ever done before. Something's got to break, and it always does. But that doesn't mean we failed, because each failed mission tells us something the successful one never could. They expose weaknesses, they highlight blind spots, they force us to improve, and sometimes they save lives down the line. In the history of spaceflight, there are missions that stand out, not because they triumphed, but because they didn't. Because something went wrong and we had to learn the hard way. Today we are going to revisit a few of those moments, not to relieve their failure, but to understand their legacy. We'll look at a shuttle that exploded in front of the world, a Mars orbiter that got lost over a unit conversion, a lander that succeeded but couldn't speak, and a telescope that almost never made it off the ground but ended up changing everything. These aren't just cautionary tales, they are stepping stones, because in the history of space exploration, failure doesn't stop the mission, it becomes the mission. On the morning of January 28, 1986, the world gathered to watch a moment of hope in history. NASA's Space Shuttle Challenger was set to launch its 10th mission. 7 astronauts were on board, including Krista McAuliffe, a schoolteacher who'd won a national contest to become the first civilian in space. Children were watching from classrooms. Families tuned in from home. It was meant to be a celebration, a moment of inspiration. And then, just 73 seconds after launch, it happened. A flash, a fireball, and the sky went silent. Challenger had broken apart live on television, in front of millions of stunned viewers. There were no survivors. The cause? Something shockingly small. A rubber seal, an O-ring, in one of the shuttle's solid rocket boosters failed due to the cold Florida morning. The seal became brittle, lost its flexibility, and allowed hot gases to escape. But the problem wasn't just mechanical, it was cultural. Engineers at Morton Thiokol, the contractor responsible for the boosters, had raised serious concerns about launching in such cold conditions. But their warnings were overruled. NASA, under pressure to keep the shuttle program on schedule, decided to move forward. The result was the worst disaster in American spaceflight history up to that point. The investigation, known as the Rogers Commission, uncovered serious flaws in NASA's internal communication, risk assessment, and safety culture. It wasn't just a technical failure, it was a failure of decision-making. But even in the aftermath of loss, there were lessons. NASA grounded the shuttle fleet for nearly 3 years. Booster designs were changed. New safety protocols were introduced. And most importantly, the agency was forced to re-evaluate the way it handled internal descent. Challenger taught the space community something brutal but necessary. That in the race to reach the stars, we can't afford to ignore the warning signs on the ground. 7 lives were lost that day, but their sacrifice reshaped how we approach risk, safety, and responsibility in space. Challenger wasn't just a tragedy, it was a turning point. In 1999, NASA launched what was supposed to be a routine mission to Mars. The Mars Climate Orbiter, a 327 million spacecraft, was designed to do something fairly simple. Observe the Martian atmosphere, study the weather, track clouds and dust storms, help prepare for future landers. No high-risk landings, no complicated maneuvers, just a quiet satellite orbiting a quiet place. But it never made it. After nearly 10 months of cruising through interplanetary space, the orbiter approached Mars for orbital insertion. A delicate maneuver that would slow the spacecraft down and place it in the correct elliptical orbit around the planet. Instead, it vanished. No signal, no telemetry, just silence. What happened? It turns out the spacecraft entered the Martian atmosphere too low, around 57 kilometers instead of 140. That meant it either burned up in the atmosphere or skipped off the edge and tumbled into space. The cause? a unit conversion error. One part of the engineering team, the spacecraft builder Lockheed Martin, had calculated force in pound-seconds. NASA's navigation team expected the data in Newton-seconds, metric. No one caught the mismatch. There was no software alert, no double check, no last-minute override, and just like that, the mission was gone. Not because the rocket failed, not because the spacecraft broke, not because two teams, both highly skilled, both experienced, weren't speaking the same language. This mistake wasn't just embarrassing, it was avoidable. But the loss forced NASA to rethink how it designed inter-team coordination. From that point on, standardized units, rigorous system engineering, and automated consistency checks became the norm. Mars Climate Orbiter never returned a single image, but its failure taught NASA something vital. In space, there are no small mistakes. Every number matters. Every assumption needs to be verified. It was a reminder that even in the age of billion-dollar spacecraft, sometimes a simple math error can bring the whole mission down. Christmas Day 2003. While most people were unwrapping gifts, scientists in the UK were waiting for a signal. A single ping from a tiny spacecraft they had just sent to Mars. It never came. The mission was called Beagle 2, a small experimental lander built on a modest budget and packed with ambitious goals. Its mission? Touch down on the Martian surface, analyze rock and soil, and search for signs of past life. It was Britain's first planetary lander, and hopes were high. After separating from the Mars Express orbiter, Beagle 2 began its descent through the Martian atmosphere. Parachutes deployed, airbags inflated, everything seemed to go according to plan. And then, nothing. No signal, no data, just silence. The initial assumption was simple. It had crashed. Maybe the parachute failed, maybe the airbags didn't inflate. Maybe the lander hit the ground too hard and was destroyed. Whatever happened, the mission was declared a failure. But over a decade later, in 2015, something surprising happened. High-resolution images from NASA's Mars Reconnaissance Orbiter showed a strange object on the surface of Mars. Bright, metallic, and exactly where Beagle 2 was supposed to land. It wasn't wreckage, it wasn't debris. It was Beagle 2. Fully intact, but only partially deployed. 2 of its 4 solar panels had failed to open, and one of them had blocked the communications antenna. The spacecraft had landed safely, it had survived entry, and it had even begun to deploy. But it couldn't call home. In a strange way, Beagle 2 had worked, just not enough. Its failure was frustrating, but it was also encouraging. It showed that even small, underfunded missions could survive the journey to Mars. That you didn't need billions of dollars to attempt a planetary landing. And it reshaped how future missions approach deployment systems and redundancy. Beagle 2 didn't phone home, but it proved something important. Even silence can send a message. Today, the James Webb Space Telescope is seen as a masterpiece, the most powerful observatory ever launched. A machine that peers into the early universe, detects atmospheres on distant planets, and reveals galaxies older than Earth itself. But for most of its life, it was a disaster waiting to happen. Webb wasn't supposed to take this long. It was first conceived in the 1990s with an original launch date set for 2007. The budget, just under $1 billion. By the time it finally launched in 2021, it was over 14 years late and had cost nearly $10 billion. It had become a running joke in scientific circles, a symbol of overreach, of mission creep, of everything that could go wrong. And almost everything did. Its massive mirror, 6.5 meters wide, had to be folded up just to fit inside the rocket. Its fragile sunshield, the size of a tennis court, had to unfold perfectly in space. There were 344 single points of failure. If any of them malfunctioned, the entire mission would be lost. And there were close calls. Tears during sunshield tests. Tears during sunshield tests, loose screws, cable snapping, delays, politics, congressional threats to cancel it entirely. But through all of it, the mission team kept going. Because Webb wasn't just another telescope. It was a time machine. A tool that could show us the first stars, the birth of galaxies, and maybe signs of life on distant worlds. And so, after decades of redesigns, tests after tests, and near cancellations, the rocket finally launched on December 25th, 2021. And it worked! Every deployment, every fold, every system, flawless. Webb went from almost failure to one of the most successful scientific instruments in history. It taught us that not all failures explode. Some creep in quietly, in delays, in funding, in politics. And sometimes the most miraculous successes are the ones that almost never happen. We remember the missions that succeeded, the moon landing, Voyager's golden record, the first image from James Webb. But just beneath those headlines, buried in silence, smoke, or slow disappointment, are the missions that didn't make it. The ones that crashed, the ones that vanished, the ones that almost didn't get off the launch pad. And yet, without those moments, the triumphs may never have happened. Because failure in space isn't a dead end. It's a detour. Sometimes tragic, sometimes infuriating, but always instructive. Challenger taught us that even the most powerful machines are vulnerable to the smallest oversights, and that no schedule is worth more than a human life. The Mars Climate Orbiter showed us how invisible gaps in communication, a few mismatched numbers, can derail an entire mission. And how we must design systems that catch our blind spots before they become headlines. Beagle 2 reminded us that not all silence is failure. Sometimes the mission works, just not the way we expected. And James Webb? It proved that success isn't always about perfect execution. Sometimes it's about refusing to give up, even when the whole world is watching and waiting for you to fail. These stories aren't just about defeat, they are about resilience. Every failed mission becomes part of the blueprint for progress. Each one leaves behind a trail of lessons, engineering fixes, and hardened wisdom that future explorers will follow. So the next time something goes wrong in space, remember this. The mission may have failed, but the knowledge it gave us didn't. Which failed space mission do you think changed the future the most? Let us know in the comments, and if you want more stories like this, grounded in science, filled with mystery and written in the stars, subscribe, because this is Spaceopedia and we are just getting started. Thank you for watching, keep looking up.